the last chapter in the course. So a Python module is a file that has a .py extension. These can be used to implement a set of attributes, variables, methods or functions, and classes or types. You can include a module in another Python program simply by using the import statement followed by the module name. To import a module named time, include import time within your Python program. You can now access the methods within the time module by calling time.methodName, or attributes, sometimes called variables, by calling time.attributeName. The following code listing is an example of using the ASCTime method and the time zone attribute from the time module. The time zone attribute includes the number of seconds between UTC, that's universal time, and the local time. Okay, so we say import time. That will import the time.py module into this program. If we then print time.ascTime, it will use that method in the time module and print the value. And if we say print time.timeZone, it will use this attribute from the time module and print the value. Whenever you import module name, all of the methods in that module will be available as module name.methodName. If you opt to use a single method in a module, you can import just that method using the from module name import method name syntax. Now the method can be accessed in your program by name. Instead of calling module name.methodName, you can now simply call method name. So here we say from time import ASCTime. So you remember we had a method ASCTime that was in the time module. So if we say from time import ASCTime, we're only importing that method. And so that now allows us to say print ASCTime. We don't have to say time.ascTime because we've already imported that method. Okay, so when we print ASCTime, we get the full time. One of the primary benefits of importing either a single method or list of methods from a module is that you can access it directly by name without having to precede it with the module name. For example, sleep5 versus time.sleep5. If you want to be able to access everything from a module, you could use an asterisk instead of a list of methods to import. However, this is not a practice I recommend. It is worth mentioning here only because you will see it used from time to time. The main reason it is best to avoid this approach is that you run the risk of overriding an existing function or variable if you import everything into your program. Also, when you import multiple methods using an asterisk, you'll find it hard to determine what exactly came from where. Okay, so we can say from time import asterisk, which means we import all the methods from the time module. And now we can use those methods directly, like saying print timeZone, print ASCTime, sleep5, print ASCTime. But the problem is if you're importing from lots of different modules, you start to get confused about where each of the methods comes from. So using the asterisk is not a good idea, but you will see it used from time to time. Peeking inside a module, you can use the built-in dir function to discover which attributes, methods, and classes exist within any one module. Okay, so if we import time, and then we do a dir time, we get this, and you see the square brackets, and then strings separated by commas and ends with square brackets, so this is a list. So this is a list of all the methods and attributes inside the time module. The module search path, keep in mind that you can always view the default module search path by examining sys.path. Whenever you supply an import module name statement, Python will look for the module in the first path on the list. If Python cannot find it, then the next path will be examined and so on. This will continue either until the module is found or until all of the module search paths are completely exhausted. The module search path may include zip files as well as directories. Python will search within the zip file for a matching module as well. It is important to note that the default module search path will vary depending on your installation of Python, the Python version, and the operating system. The following code listing is an example from a Python installation on a Mac. So here we've got import sys, then for path in sys.path, print path. So because sys.path is a list, this for loop will print each item in the list. Okay, so the output is user/David, library frameworks python.framework version 3.4 lib python34.zip. So this zip file will contain one or more modules, and so these will be searched. And then we've got this python.34 path, so this path will be searched, and so on. So whenever you import from modules, it will look through all these paths until it finds it, and it will throw an error if it's not in any of those paths. The show module path.py file was located in users David when I first executed Python 3 show module path.py. Notice that users/David is listed first in the module search path. The other directories were decided by the Python installation. Okay, so this sys path depends on how Python was installed. If you want to ask Python to search other locations for modules, you will need to manipulate the module search path. There are two ways you can do this. The first method is to modify sys.path just as you would any other list. For example, you can append directory locations by using a string data type. Okay, so if we import sys, now we've got sys.path as a list. We can now append to that list another path. So this is adding this path to sys.path. If we do a for path in sys.path loop, and it prints all the items in that list, you'll see that users.David Python has been appended to the end of the list. And that now means that we can do an import of modules that exist in this folder. You're also able to manipulate the Python path environment variable. This variable acts in a very similar manner to the path environment variable. On Mac and Linux systems, Python path can be populated with a list of directories separated by colons. On Windows systems, the Python path environment variable requires the use of semicolon in order to separate the list of directories. The directories listed in Python path are inserted after the directory where the script resides and before the default module search path. In the following example, users David is the directory where the show module path.py Python program resides. The users David Python and user local Python modules paths are included in the Python path. The export command makes Python path available to programs started from the shell. Okay, so if we're in the command box and we say export Python path equals users David Python user local Python modules, then this will export this and it can now be used in the shell. So here, if we now run Python with show module path.py, it's going to include everything that's in the environment variable. And you can see this because we exported Python path equals users David Python and user local Python modules. So you see here, users David Python, user local Python modules. If you are unable to find a module within the search path, an import error exception will be raised. So if you say import say hello, and that module doesn't exist in any of those paths, then you will get traceback most recent call last. You get an import error, no module named say hello. The Python standard library. As we worked through previous examples, we have been using the time module, which comes included with Python. In fact, Python is supplied with a large library of modules for you to take advantage of. I would highly recommend that you take some time to really look at what the Python standard library has to offer before you even think of writing any of your own code. For example, if you are looking to read and write CSV, that's comma separated value files, don't waste your time creating something from scratch when it already exists. Just use Python's pre-existing CSV module. Are you looking to enable logging in your program? Well, there's a logging module which can help you to do that. Do you want to make an HTTP request to a web service and then parse the JSON response? Try using the URL lib.request and JSON modules. To explore these modules and more, check out the list of what is available in the Python standard library located at https://docs.python.org/3/library. And let's just take a quick look at that now. So I'm opening up this page. This is the Python standard library, and this now tells you what's in the Python standard library. So while the Python standard library reference describes the exact syntax and semantics of the Python language, this library reference manual describes the standard library that is distributed with Python. It also describes some of the optional components that are commonly included in Python distributions. Okay, so if we go down here, we've got introduction, built-in functions, built-in constants, built-in types, built-in exceptions, text processing services. Let's just take a look at built-in functions. Okay, and you can see there's a long list of built-in functions. Okay, so all of them are described here. So it will be worth your while to take a look through here, and whenever you want to create a program to do anything, first look here to see if it has already been done for you. Okay. Now let's use the exit method from the sys module to cleanly terminate your program if it detects an error. In the following example, the file text.txt is opened. If the program encounters an error while the file is opening, the code block following except will execute. If the reading of test.txt is mandatory for the remaining code to function correctly, there's no need to continue. The exit method can accept an exit code as an argument. If no exit code is provided, 0 will be used. By convention, when an error causes a program to exit, a non-zero exit code is expected. Okay, so here we import sys. Now we're saying file name is equal to test.txt, and we try with open file name. So we're opening this file as test file, and then for line in test file, print line. So we want to go through this file, reading all the lines. If it fails to open the file, it throws an exception. And so now we can print could not open the file name, and then we call sys.exit1. So this will exit cleanly from the program. It closes everything and ends the program. Okay, creating your own modules. Just as Python has a library of its own reusable code, so can you. It's quite simple to create your own module. Just remember that in its least complex form, modules are files that have a .py extension. Simply create a Python file with your code and import it from another Python program. The following code listing is the content of sayhello.py. So we define sayhello, and it prints hello. Sorry, this needs to be indented. Note how you can import and use the sayhello module. To call the sayhello method within sayhello module, use sayhello.sayhello. Okay, so we import sayhello, and then we say sayhello.sayhello. Okay, the output should be hello because we've imported this module, and the module defines this function sayhello, so that when we say sayhello.sayhello, it will print hello. The following example is another simple module called sayhello2. The following code is the body of sayhello2.py. Define sayhello, print hello, and print hello from sayhello2. Okay, so our module sayhello2 consists of this function definition, and it also has a print statement in it. So let's find out what happens when we import sayhello module. If we import sayhello2 and then we say sayhello2.sayhello, the output is hello from sayhello2.py and then hello. Okay, so what is happening here? When we import sayhello, it defines a function, but it also prints hello. So as soon as we import it, it will print hello from sayhello2. It executes this line. Then when we call the function sayhello, it calls that function and it prints hello. Okay, so what happened? Well, when we say hello2 is imported, its contents are executed. First, the sayhello function is defined. From there, the print function is executed. In this way, Python enables you to create programs that behave one way when they are executed and another way when they are imported. If you would like to be able to reuse functions from an existing Python program, but have no desire to execute the main program, you can account for that. Okay, using main. Whenever a Python file is executed as a program, the special variable name will be set to main. Notice that there are 2 underscore characters on each side of the names of these special variables. In instances where it is imported, the name variable will not be populated. Ultimately, you can use this to control the behavior of your Python program. The following code example is the sayhello3.py file. So in this module, we define a function sayhello, which prints hello. We define a method main, which prints hello from sayhello, and then it uses this method to say hello. And then we end with if name equals main, then we run main. So whenever it is executed as a program, the code block following if name equals main will be executed. In the following example, it simply calls main. This is a very common pattern, and you will see this within many Python applications. When sayhello3.py is imported as a module, nothing will be executed unless explicitly called from the importing program. Okay, so here we execute. We're calling Python 3 sayhello3.py. It will print hello from sayhello3.py because it's calling main, and then it will execute. It will print hello. Okay, review. Python modules are files that have a .py extension and are capable of implementing a set of variables, functions, and classes. Use the import module name syntax to import a module. The default module search path will be determined by your Python installation. To manipulate the module search path, modify sys.path or set the Python path environment variable. The Python standard library is a sizable collection of code that can be reused within your Python program. Use the dir built-in function to find out exactly what exists within a module. You can establish your own personal library by writing your own modules. You can influence how a Python program behaves based on whether it is run interactively or imported by checking the value of name. The if name equals main syntax is a common Python idiom. Okay, so that's how we get a module to execute one way if you execute it directly, and execute a different way if we import it from another module. Okay, exercises, PigSpeak, Redux. Update the PigSpeak program we discussed in Chapter 1 so that it can be imported as a module or run directly. When run as a program, it should prompt for input as well as display a pig saying what was provided by the user. Place the input provided by the user inside a speech bubble. The speech bubble can be expanded or contracted to fit around the text, the input provided by the user. The following code listing shows the sample output when run interactively. Okay, so here we've got a pig, and it says pet me and I will oink. Okay, so from here, create a new program called pigtalk.py that imports the pigsay module, and try using a function from the pigsay module to display a variety of messages to the screen. The following code listing shows the sample output when used as a module. Okay, so we create a new program and we import the pigsay module, and then we call the pigsay method from that module to get the pig to say different things. Okay, and as usual, I'll skip over the solution. Okay, this is the end of Chapter 9, modules, and the end of this course. I hope you have learned a lot and would like to learn more about the Python programming language or anything about computers and programming. So I hope to see you soon in another Computer Science Learning Series course.